And then we can have discussions or whatever afterward. Yeah.
Definitely. Okay, you're on.
Awesome. Okay, so hello. One of the previous videos that we talked about was hooking up GitLab into AWS to build instances through Terraform. And today I wanted to show a more complete state of that earlier demo. All right. So with that, let's go ahead and share here. Okay, and you can see my screen. Okay.
Yeah. Yeah.
All right, perfect. So just so that there's no fooling here, I just wanted to show that this is just a Chromebook. All right. This is no special device that I had before. You know, I had a Linux workstation that I was using. This is just vanilla Chrome OS, right? Okay. So what we've set up here is on GitLab, right? I've built out several different files, and we'll kind of talk about those, and then we'll show it in operation, right? So there's this Terraform configuration file that holds my Terraform main that contains everything that I would need in order to spin up a single EC2 instance wherever I specify in AWS, right? And then what might seem strange to any Terraform aficionados out there is this part, where we're now saying what the backend is. So normally with Terraform on your backend, you're specifying like a local backend, right? So you'll have a local Terraform TF state, right? So here's an example of a Terraform that I've done locally, and you have this TF state. So what is this TF state file? Well, this TF state file is what contains the different bits and pieces of information that Terraform needs in order to talk to whatever provider that you're sending it to. It's generated for the first time you run a Terraform init, which is what initializes the playbook. Okay. So that's that. And let's look at this next piece, and then we'll talk a little bit more about why sort of setting up some of this might actually be dangerous, and why it's actually secure, and then how you might actually use this for red teaming once we actually show the system in production. So we have this Terraform, this GitLab CI YAML file, which is a CICD pipeline file for GitLab. And all this really says is that the GitLab CICD is like it's like a Docker that they have on their backend, but you can specify things to it through YAML. And some of the things that it has is you can define like stages, and then like what it's doing, like Terraform, and then variables that it needs to pick up with. And then a very specific variable that we need to think about is this deploy to string. So normally in CI/CD, you'll have it set up through environmental triggers, but you can also set up to be manual. In this case, I set it up to be manual through this deploy to variable. And all this does is this does the initial Terraform init, and it stands it up. But what's unique about this is that it's using this Terraform S3 bucket. So the Terraform state actually lives in a Terraform, in an S3 bucket on AWS that costs me nothing because it's all on the free tier, even the instance that this is deploying on the free tier. So that's how you get around actually needing to have your Terraform state on your local computer, is you put it somewhere remote. And doing it this way through the bucket means that we can now configure access to everything through AMI on AWS, which is the Access Identity Management. And this allows us to control what can talk to it and what are the levels and permissions that it have. If I put this Terraform state file into my GitLab repository, then anybody who had access to my GitLab repository might also have access to the credentials to AWS and other things like that in order to see the different configuration information that I have. So that's something important to pay attention to. Like if you're ever thinking about doing anything against infrastructure as code or trying to defend infrastructure as code, is that who has access to see your repository would also potentially have access to some of your infrastructure as code that would contain the information that would allow them to break into your system. And so here it is, right? So we have this staging. So we say that there's this stage that we want it to use, and we call it staging, right? And that is what's actually going to put everything into AWS and actually create everything, right? So just to show that I'm not fooling, right? Let's go to the same region that has everything that contains my instances and what I need. And we'll go to our instances. So we have 2 instances running right now. And these are essentially to run this GitLab runner, which is a Docker that listens for CICD connections from my GitLab and then builds what I need inside of it. And so if we go back to our GitLab and we go to our CICD, right, we have these pipelines, and these pipelines are essentially pointing to that GitLab runner. And the GitLab runner is just waiting for information to go ahead and pick it up. So if we go into our runners, we see that we have 2 runners running here, right? We have one is the shell runner and another is this Docker. So these are those 2 instances that you're seeing here that are tied into the CICD. I've generated a GitLab runner token, and that gives us access to the AWS CLI and the Terraform CLI package in order to pick up the code that's being pushed from GitLab into AWS. Okay, that's great, but there's a few other things. So in order to get all of this to work, I had to do some things which are called CloudFormation, which essentially is these template files, or you can graphically set these up, that essentially set up everything that you would need in order to scale up multiple Amazon AWS resources, all from a single file. Other cloud providers have similar types of things. This is some infrastructure as code. So we have a runner role that sits on the AIM. And this runner instance profile picks up from this AIM role. We have this runner launch configuration, which is for auto scaling. So it's going to be able to scale our instances whenever it picks up from the AWS CLI. We have an auto scaling group where everything is controlled. And then we have scale down at night and scale up in the morning, so we can schedule what times we want everything to be picked up. We have the runner lifecycle topics. So this contains a group of different statements and other things like that everything is going to connect to. We have an unregister function, which will delete all GitLab runner instances. So all our EC2 instances, if we trigger that from GitLab, this is just a Lambda function. So this is a serverless function that's connecting into AWS. And then a few other things that we have down here is that the runner unregister policy depends on this AIM role, and this runner lifecycle policy, which will actually run everything and have the ability to run everything, also depends on this AIM role. All right. So the next part that we have the S3 bucket, and all that is an Amazon Dynamo table. And so that's like a NoSQL database that AWS has. And so what this is essentially saying is that it has 2 roles. It has a Terraform role and it has an S3 backend role. And it connects to this table, and this table eventually connects to the state bucket. And this is where all of those Terraform state files are held. And that has like our Amazon AWS access credentials. That has what we need in order to talk back to GitLab and all of that. And so those connections, when they're set up like this, we can encrypt these, so they're no longer there. However, And you'll see why I say however here in a second. So we're going to go back to CloudFormation. These are each of our stacks. And we're going to see that these stacks actually talk to each other, right? So the GitLab runner, whenever you create the stack, is going to have outputs that you define in there. So it has like my account ID and other things like that. And this is just like a throwaway account for school. So this gets deleted every day when I'm done using it. So no big deal. And then this has like our bucket name, and it also is tied into the same account ID as our GitLab runner. And it also is pointing to the same region. Okay, so with all of that, this is just a really fancy way to essentially do nothing more than spin up our instances. And I'll kind of show that right now, right? So we want to build our instances. So we're going to hit run pipeline, right? And then we'll talk about a few of the red team ideas that you need to think about for CICD. So we saw from our files that the string that we need is that deploy to string from the GitLab pipeline, right? So until it hits, so none of these stages, like the deploy stage or anything like that, is dependent if deploy to equals staging. And we've also set up other pipelines, right? So deploy to is production, right? So let's say that we're just trying to scale up one instance for our staging environment so that our developers can start working on it, or a pen tester could start accessing it. So we'll put the input variable key is deploy to, and the value is staging. So we'll hit run pipeline. All right. And there we go. So I'll go into deploy staging, and it hasn't picked up yet because it's waiting for this GitLab runner in order to pick up that job. And hopefully this works. And this will overwrite our latest deployment, and this will create our staging job. So we'll just kind of give it a wait here. And if it doesn't, then I'll move on to some of the other pieces of the talk. All right, so there it goes. So it's been picked up by the shell runner. So GitLab runner is running, and it's running on that shell runner, which are those instances that you see over here. So you can see those by the instance IDs. And it's fetching the resources from Git. So it's pulling it actually from our GitLab. It's removing the old .terraform state. And now it's building everything. And not a Terraform state. This is just like a Terraform file that was in master, because it's checking it out. It's deleting everything that was already on the runner, and now it's bringing everything new to build it fresh. So it's picking up what kind of platform it needs to build. It's starting the setup script. So it's doing the Terraform init, and it's saying, hey, save your backend into this bucket in this region. And here's the roles that I've helped configure for you. Deploy into this account for that role S3 backend, and set the session name as Terraform backend and do a Terraform configuration. So it's successfully configured the S3 backend. So normally you would have to point and click and drag a bunch of files in order to get this all set up on AWS, but this is doing it all through code. So a process that would take you 30 minutes or more takes a couple minutes to spin up. Terraform is successfully initialized. So now it's creating it's going to create our instances. It's going to not set any passwords or not set any SSH keys or anything like that. It's just going to set up the instance that's configured to the account. It's going to set it up in a subnet, and it's going to apply the configurations, and it's going to create everything. And then at this point, the job has succeeded. So now we go over to our instances. And if we go back to our dashboard, where we had 2 instances, we now have 3 instances. or we should have 3 instances. Okay, cool. So now we have a second instance that's being initialized here. And now that this instance is initialized, we could connect to it, right? We could set up our SSH keys, provide that to a user or maybe somebody outside of our company. We could go in and we can already see that it's provisioned into a security group. It's got no ports set up for it, other than it's saying that 0.0.0 can access it, but that's just the outbound rules. There are no inbound rules that are set other than from what's inside our security group. So only things inside of our security group can talk to it. We could normally have defined all of that within our security group and all of that. So all of the buttons that you would normally click to build your instance and provision your environment, this has already done it for us. So now we could connect to it if we wanted to. Okay, that's great, but why are we able to connect to all of those different things? So let's go into our CICD, right? So in GitLab, you have the different options to set up the ability to like scale and test your code through these CICD options. And you can schedule jobs and set them all up. But in order to do that, you have to set up some kind of backend. So GitLab out of the box provides some automated testing and deploying that you can automatically set up. And it does come with default runners that will test your code and other things like that, as long as you've provided the right information to it. But in our case, all we've really done is set up a remote GitLab runner, and we've set up some variables. And so we've said the account ID, which is what you saw in the S3 bucket, and then the region where we want it to go, and then the S3 URI that we want it to go to. However, we've also set up an external ID, which means that as long as the external ID is in the S3 bucket and stored here in GitLab, then they're going to be able to talk to each other. And so this is really our only vulnerability within this setup, unless somebody got access to the AWS account, is this external ID. This is a shared ID that you have to set up inside of your AIM manager. And when you do that, you're also setting it up so that somebody could get access to these instances if you have provided that. And I'm just clicking through to try to remember where that role is. And that's in our policies, right? So we've defined some policies in here that allow us to have access to all these different things. Like we've said, we have administrative access and all these different things like that. But we've also said that there's an external ID that's set up in there. And now I've completely forgotten where that is. So just bear with me 1 second while I get to that. No.
Did you configure that within your CloudFormation config file, or was that from
Okay.
GitLab?
Yeah. So that external ID is actually set within the S3 bucket itself. So let's just kind of go to that, and then maybe that'll spark my memory again. Anyway, you'd set it up in here. You'd set it up as an external ID to the bucket. And then you oh gosh, because I just did this morning. So anyway, for the sake of time, let's just go to the S3 bucket. Like, let's just assume that you found where that external ID is in here, and maybe it'll jog my memory. But you go into this S3 bucket and you would say update, and then you change the template to have this external ID key, right? So we've set this assumes role is Dave key. And so this is the only key that gives access to GitLab into our S3 bucket. And that's an external ID parameter. And I don't exactly remember where I set that up, but that's okay. Sometimes when you're working through things, you forget, and this is why it's always a bad idea sometimes to run solo on some of these activities, because you will do things and you'll create things and then you forget. Okay, so S3 backend, there it is. Right. So here's our role.
Nice.
So we've said we've set a trust relationship, right? So that's how it is, right? So if we needed to have external entities trust items and objects within our S3 account, sorry, our AWS account, we would set that as a role, right? So this is like users from other corporate accounts or AIM users in another account. Because there's actually multiple accounts that are going on here, right? Like there's a root user who has access to all of these instances and can spin things up and spin things down. And then there's this AIM DevOps user that only has access to like the GitLab runner and the S3 bucket, and they don't have access to anything else. The only thing that's allowing that access is this trust relationship that's setting this external key Dave. Okay, so there's all of that. And let's say you wanted to spin down your instance, right? So there's several different things that are going on in here. And let's just say that we wanted to delete everything. Okay, so then all I have to do is I go in and I click stop staging. And this is going to kick off another line in our pipeline. And it's going to be picked up by the runner here momentarily. And that runner is going to go into our EC2 console, and it's going to delete this instance. Now, how is it able to do all of this? Well, it's able to do all of this because Terraform speaks the API of AWS, and Terraform can speak the API of most cloud providers. So let's think about this here. If I had access to that external ID, I could theoretically, if somebody had set this job up, because there are a lot of GitLabs and GitHubs that are public access, if I could figure out what that external ID is, I could potentially start pointing different elements of their CICD pipeline to my resources. And I could start spinning things up and spinning things down. So what it's doing here is it's just running a Terraform Destroy. And the only thing that's going to be left behind is our GitLab runner and our S3 bucket. So how would that necessarily be useful for red teaming? Well, if this was and I'll let this run before moving on to pointing that out. And so that's done. And just to show that the instance has been destroyed, we're going to refresh, and now the instance is gone. So how could you leverage this for red teaming? Well, number one, understanding how these different components of AWS are configured and put together, even though I'm just a novice at it and I've never actually gone out and attacked anything in AWS. I could assume that based on going through this process of setting up this CICD pipeline, there are multiple areas where you could have information leaking. Number one, if you were just doing this where you were setting it up in, say, Gitpod or locally on GitLab, and you weren't storing the Terraform states outside of the GitLab project, then somebody who has access to it could potentially also then get access to your AWS credentials. We may not necessarily care so much about somebody getting access to our GitLab credentials as we would somebody getting access to our AWS credentials. If somebody had access to the external ID, then they could potentially start pointing buckets to different resources in order to put different information inside of it or pull information out. And so how could you then leverage these same ideas? Well, this is also called Git Ops, which I guess is like DevOps. Those are just terms. What I'm understanding is that this is just a way for you to scale up resources to have everything controlled through Git, right? So you could also go into your CICD pipelines here and schedule these different jobs to pick up on different branches. So the master branch based on a different variable key that goes in. So I could say on Monday, go ahead and build staging. And then let's say I know by Tuesday or Thursday, somebody's going to have new code checked in. Go ahead and kick off the production pipeline. If I was doing this for red teaming, I might then be able to start spinning up my attack resources, like maybe my my jump boxes or machines to catch reverse shells, or my scanners based on schedules that I've picked up from how does the target behave and operate in terms of their work, right? Do I know that most workers are not going to be there Friday 5 p.m.? Okay, most people are going to check out at Friday at 5 p.m. and I might be able to see that based on like status changes that are going on Facebook. Maybe they don't have great operational security. Then I might be able to start configuring my scanners to kick off at 5 p.m. and then pick up the results of that and build different things based on new variables that are being dropped into files that this CICD is looking at. So just kind of thinking like, this was just a small demonstration to show the power of Terraform and GitLab combined and the CI/CD capabilities of GitLab, but also start thinking about that when people are setting up secure resources, you try to limit the amount of information that's being shared by these different platforms. And there is a weakness to my design, right? It's that external ID. That known external ID is part of the third party that's being shared, and it's also the name of my S3 bucket is being shared between my runner and all of that, and my runner always has to be on. So if that's the case, and you wanted to target my CI/CD, you would target either my GitLab runner, which you may not be able to do because it's sitting behind a security group and it's sitting on private subnets, but you might be able to touch my bucket. And because you might be able to touch my bucket and you have a shared external ID, you might be able to start figuring out a way to get into the GitLab runner. And so with that, that concludes my demonstration. I can either stop sharing my screen or I can leave the screen up if anybody from the audience wants to kind of have me dig into another topic that I was showing on the screen.
Yeah, so one aspect that I'm sort of a little bit unclear of still is that I thought it was really cool that you're sort of creating those runners on AWS and you're doing the necessary configuration so that GitLab and terraforming and the AWS is able to sort of interact with each other, and your runners and your S3 buckets there are running there on AWS. But so my point of confusion is like, so when you ran that command to kill your instance, and run different, like you're saying, there's scheduled commands or scheduled pipelines you could run, right? Is that running on some machine on gitlab.com somewhere? Is that how it works? The kickoff of the different commands that you're running for the pipelines?
Excellent question. So by default, and let's just pull open the settings, right? So by default, if I was setting up CICD pipelines on GitLab, and this is just like public GitLab, I don't own a GitLab server. I don't have an instance. All of these shared runners are then set up on gitlab.com. And they are sitting on the Google Cloud platform, because that's, I think, where GitLab actually runs, is on the Google Cloud. And you're limited by the amount of time that you have, but they would pick all of that up. When you're doing it this way, what's actually happening is that there are, I believe it's HTTP calls, but I'd have to dig into a little bit more. There are, or it's probably even REST calls that are being made. These two instances that you see here, right? They have a token that I have provided to them, this token here, that has set up access to the shell runner and to this Docker that contains the GitLab runner sitting on AWS. And the way that I set that up, there's a better way, there's probably a better way to do it, but I found a template file for these CloudFormation stacks, and that set up the ability to like hook in AIM and hook in all these different pieces. But all this essentially is you would go install the GitLab runner, and to do that, you would just download a Git repository, and you would you'd install it on Linux, right? So we could install it on Linux, or we can install a Docker image. And these binaries, if it's done in a manual way, or if it's through the repository, then sits out and waits for these calls to come in from the GitLab repository to start building things. In our case, we're using a Docker image, and I could possibly pull up that template file. Yeah, let's pull that up. And then maybe that will make it a little easier to type modified date. Okay. Oh yeah, that's right. So yeah, here it is. Okay. So let's open with Sublime Text so that you can get a better view. And Sublime Text is going to go. So answer to your question, Candy, what's actually happening is GitLab kicks it off, and then it talks to this GitLab runner. And this GitLab runner is this Docker, right? So this Docker knows the URL of our GitLab server, and it knows its EC2 instance ID. And so this Docker picks up the token that's coming in, picks up the call, the web calls from the GitLab server, and then it actually starts running whatever we've sent it to through the GitLab runner CLI commands. And that's where it's running Terraform and the AWS CLI. So this doesn't actually live, right? Roundabout way of answering your question. This doesn't actually live on the GitLab server. All this is just you're clicking a button that's initially sending a call, a web call, to the GitLab runner in an encrypted state. So I hope that answers your question. Maybe it does, maybe it doesn't.
Yeah, it definitely answers it. But then, so that last config file, that template file that you were showing. So one thing I wanted to sort of get clarification is like, and you sort of mentioned it, you know, you have variables such as the IP address of the GitLab server. So like you're saying, as a part of the REST API, when you're sort of clicking those buttons, that's how I believe, like you're saying, it's all encrypted. That's how the information is given to the AWS side. So then the AWS can sort of populate those variables and then sort of finish the different stages. Is that correct?
Yeah, absolutely. Yeah, okay. That's absolutely correct, right? So if we look here, right, so this is just a design viewer, right? So we could click on this, and the way that you would use design viewer is like you just click and drag these different instances items in here, and then it automatically populates it for you so that you can start operating on it, right? And so it'll have like the IDs of what it is and then the other things like that. So I'll just delete that one because we don't need it. And so exactly, right? So like as you're clicking those different buttons, right? Like you're also filling out those fields, right? So you're saying like when you're setting up EC2 instances and things like that, you're saying like, hey, this is going to connect to this. Hey, this is going to connect to that. Hey, this is going to connect to this instance or this resource. And by setting it up in a file like this, right? I'm not super pro or anything like that. I followed a tutorial online. I followed this guy's tutorial in Visa, and right, like they talked about that. I followed, you know, a couple things from a Medium article, and then like a number of other resources. And all they were really talking about, right, is like, yeah, you have these template files and you can create these template files like in JSON or YAML. And all those really are is you're like clicking and dragging these different like AWS resource types that you want, and then you're building it. So think of it as like, this is the AWS version of Terraform, right? Like it's it's just a way for you to like start adding things in to build things out. And so like this is where you can set like your descriptions and other things like that, and like what type of Docker you want to use and other things like that. And that corresponds to like these different topics that you're setting, right? So you're saying, or not topics, like these different objects and resources, right? So you're saying like, if you clicked on them and you dug deep into them, you would be scaling everything and writing everything based on like this kind of YAML-like language. So I hope that kind of answers a little more of your question.
Yeah, it definitely does. That was great, Dave. Thanks.
Yeah. And as I'm going forward, right, like this is part of some schoolwork that I'm doing, and I hope to kind of scale this, because the idea is basically like, once you have the runner set up, and as long as Terraform knows those different variables, right? So let's kind of go back to that Terraform file, right? So as long as it's got these variables and it knows where these variables are, you're setting those in the Terraform main TF file in very much the same way that if you were doing this, you know, normally, like in regular Terraform. And I will just find that real quick. My senior seminar, learn Terraform modules, and then main.tf. Yeah. So in the same kind of way, right? Like when we're saying for what you're seeing in the GitLab, right? Like the region, that region doesn't just becomes a string. And so those different variables. So it's just a way for you to have more control over your Terraform file, right? That's all this really is. And the same thing with like what you're seeing with this CloudFormation stuff. These are just ways to quickly scale up like a large number of resources that you need inside of AWS without having to individually click a bunch of buttons. So this becomes really important if, say, like Candy, you built a like a Chisel C2 framework, and you needed to bring that Chisel C2 framework quickly into another environment. If you had these files and you had a CICD environment like this, you could rapidly bring all of those different pieces together and set up the different variables and everything like that. So yeah, that's about it. It was really important that I showed that, you know, this is all stuff that was essentially done just through the browser. So nothing super crazy, right? Like no special code, no special anything that was needed. Just GitLab and AWS and some Googling.